It's
Sure.
raining near our home.
No, uncle, it's only cloudy.
Okay. Issues. Let us share the screen. You are able to do that third sum.
No, uncle, I didn't have time. School itself, they give around 5 sums for homework.
Yo.
Hmm.
Okay. No problem. We will continue with the exercises.
Sure.
Okay, third sum you do sometime.
Okay.
Okay, maybe weekend you can do third sum. It's easy only, 5 minutes only. Solve the following linear programming problems by graphical method. Let us do graphical method. Okay, because you said graphical method is tough. Then we'll do 3 problems here. 3 problems you can try at home. Giving 5 sums for homework, huh? Not bad. I thought they are giving less sums for homework. That means very less they are doing in class, giving everything for homework. Okay, let us do. First sum we'll do. Okay. This is exercise 10.1, fourth sum. Okay, first one. It's telling Z is given, maximize Z is equal to 6x1 plus 8x2 is given. Constraints are given 30x1 plus 20x2 equal to 300. Less than or equal to, you must ignore the less than or equal to. Okay. And another constraint is given 5x1 plus 10x2 is equal to 110. The other constraints x1 greater than 0, x2 greater than 0. That means it is in a positive first quadrant. Okay, we'll take it like that. So here first put x1 equal to 0, then 20x2 becomes 300. Then x2 becomes 300 by 20. Okay, 30 by 2, 15. So 1 point you are getting is x1 equal to 0, x2 is equal to 15. Okay, this is point A. Then another one you should take is x2 equal to 0. When x2 is equal to 0, 30x1 equal to 300 it becomes. Because whole of x2, 20x2 goes out. x1 is equal to 300 by 30. That is 10. x1 equal to 10. So x2 is equal to 0. The point you are getting is equal to 10, 1. Okay. First point you are getting is 0, 15. Second point you are getting is 10, 1. Now let's take this other one. 5x1 plus 10x2 is equal to 110. Here you take x1 equal to 0. 10x2 is equal to 110. So x2 is equal to 110 by 10. It's equal to 11. Okay. So the point is 0, 11. Take x2 is equal to 0. Then the equation becomes 5x1 is equal to 110. x1 is equal to 110 by 5. Okay. Those 2 times in 10 it goes 2 times 22. x1 equal to 22. So 2 points are there. 22, 0. This is the second point. This is the first point. Okay. Now you got 4 points. So first let us take 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22. Okay, this is 22, 0. Okay, 0, 11, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, like that. 0, 11. Okay, 0, 2, 4, 6, 8, 10, 11 is here. 0, 11. From 0, 11 to 22, 0, you have to draw a line. Okay. That's the second line. 5x plus 10x equal to 1. First line is 0, 15 to 10, 0. 0, 15, 2, 4, 6, 8, 10, 12, 14, 15. So this is 0, 15. 0, 15, 10, 0. 2, 4, 6, 8, 10. So this point is 10, 0. So from here you have to draw here. Okay, here you are intersecting. Here you are intersecting. Okay. Now it's telling maximize. So maximize means you have to take this one. This area. Okay. What is this point? So this point 0, 0, 0. This point A, 10, 0. This point B, which you have to now find out. This point is C, 0, 11. Okay. So you got 4 points. Which of the maximum of that 4 points only will give you thing. Before that, we have to find out B. How to find out B? B you have to find out by finding out the intersection of 30x1 and 20x2 is equal to 300 with 5x1 plus 10x2 is equal to 110. Now this, if you multiply the second one by 2, you'll get 20x2, 20x2, you can cancel. Okay, so 30x1 plus 20x2 is equal to 300. This is multiplied by 2. 10x1 plus 20x2 is equal to 220. So subtract. This will get cancelled out. 30 minus 10, 20x1 equal to 300 minus 220, 80. So x1 is equal to 80 by 20. That's equal to 4. X1 equal to 4. Now substitute that in any one. Okay. Substitute that in any one. Let us substitute in 5x1. 5 into 4 plus 10x2 is equal to 110. That means 20 plus 10x2 is equal to 110. 10x2 is equal to 110 minus 20. That's equal to 90. So that means 10x2 is equal to 90. x2 is equal to 90 by 10 is equal to 9. So x2 is equal to 9. x1 equal to 4, x2 is equal to 9. So this one is 4, 9. Okay. So all the 4 points that you want, you have now got. You have to find Z max. Z max you have to find. Okay. What is Z equation? Maximize Z for 6x1 plus 8x2. So first is Z point is 0, 0. You find the values. What you value? 6x1 plus 8x2 you find values. Second one is 10, 0. For that also you find. Third one is 4, 9. For that you also find values. Fourth one is 0, 11. To find values, out of which is maximum will be Z max. 0, 0 is 6x1, this is 0. 8x2 is 0, this is also equal to 0. 6 into 10x1 plus 8 into 0, that is equal to 60. Okay, then 6 into 4 plus 8 into x2 is 9. How much is that? 24 plus 72. 72 plus 24, how much? 6 and 9. This is 96. This so far is high. Then 6 into 0 plus 8 into 11. 8 11s are 88. Out of this 3, 4, this is the greatest. So Z max is equal to 96, where x1 equal to 4 and x2 is equal to 9. This is your answer. All right. It's very simple. What will be the difficult point is finding this point B. Point B is found by finding the intersection of both this line with this line. This line is what that line? 30x1 plus 20x2 is equal to 300. That is that line. This line is what? 5x1 plus 10x equal to 110 is that line. Okay. So you solve simultaneous equation, you get common x1, x2. That point only will be meeting point 4. That's all. Okay. So actually the graphical method is very easy and simple. But you feel it is tough, right? We will do one more problem. Again, you tell if it is tough or it is easy.
Yeah, uncle, we'll do one more problem.
We'll do two more problem.
Sure.
Let us do a minimize problem. Which one is minimize problem? Third one is minimize problem. Okay, let us do third problem. Minimize problem. Minimize z equal to 3x1 plus 2x2. So fourth one, exercise 10.1, fourth one, third problem. So minimize, very important. Minimize z equal to 3x1 plus 2x2. Okay, that. That means lowest you have to get. What are the constraints given? 5x1 plus x2 is equal to 10. That greater than, less than, all that you have to draw. Then x1 plus x2 equal to 6. Then x1 plus 4x2 is equal to 12. Then usual constraints, x1 greater than 2. This is negativity constraints, x2 greater than. So this is also in the first quadrant. Let us draw the first quadrant. Draw the first quadrant. Minimize x equal to subjective constraints. Okay. Here 5x plus x1 equal to 10. Now take x1 equal to 0. 5x1 will become 0. So x2 is equal to 10. So first point is 0, 10. Okay. So 2, 4, 6, 8, 10. This is 0, 10. First point. Okay. Then take x2 is equal to 0. x2 is equal to 0 means 5x1 equal to 10. x1 equal to 10 by 5 equal to 2. Okay, so this point becomes 2, 0. This point becomes 2, 0. I think I messed up. 0, 10 will come here. 6, 8, 10. Okay, this is 0, 10. Okay, let us rub this off. Zero, 10, and this is 2, 0. 2, 0 is this point. Okay, so this line goes like this. 2, 0, this line like that. Then next line is x1 plus x2 equal to 6. Now let us take x1 equal to 0, x2 becomes 6. So 0, comma 6 is the first point. 0, comma 2, 4, 6. We have 0, comma 6. Then take x2 is equal to 0, in which case x1 equal to 6. So here we have 6, comma 0 as the point. So 1, 2, 3. This is the point. 6, comma 0. So 0, comma 6 to 6, comma 0 will go like this. Like that. Okay, this is the second line. Third line is, let us say, x1 equal to 0, then 4x2 is equal to 12. Then x2 is equal to 12 by 4 is equal to 3. So this point becomes 0, comma 3, first point. Okay. 0, 2, okay, this is the place. 0, comma 3. Now what you have to do, x2 is equal to 0. x2 is equal to 0 means 4x2 is equal to 0. So x1 equal to 12. So what will that point be? Point will be 12, comma 0. Okay. So 0, comma 3 to 12, comma 0. 12 is 2, 4, 6, 8, 10, 12. Okay. 12, comma 0 is the actual point. So this third line we can draw like this. Third line we can draw 0, comma 3 to 12, comma 0. So 3 lines are drawn. Now, what he's telling is minimize. Minimize means, what is the problem with minimize? You have to take this side up to here, then up to here, then up to here. And which direction the function goes? Function goes this direction. Okay. Now what we have to do? We have to find 2 points. This point and this point you have to find. Okay. First line and second line intersecting is this point. Okay. So let us name this as A, this intersecting point as B, this intersecting point C, this intersecting point D. D is equal to 12, comma 0. Okay. This is D. D is 12, comma 0 already given. A is equal to 0, comma 10 already given. Okay. You have to find B and C. B and C are nothing but intersection of first line and 6, comma 6, 6, comma 6. Yeah, x1, x2. This line is intersecting with 5x1 plus x2 is equal to 10. First line. Yeah. You can directly subtract. If you subtract, this will go off. 4x1 will be equal to 10 minus 6 is 4. So x1 equal to 1. So 1 plus x2 is equal to 6, substituting in this one. Okay. So x2 is equal to 6 minus 1 equal to 5. So x1 is 1, x2 is 5. So the point is 1, comma 5. What is this point B? This point B is 1, comma 5. Same way we have to find point C. Point C is the interaction of x1 plus x2 is equal to 6, second line, with the third line, x1 plus 4x2 is equal to 12. x1 plus 4x2 to 12, yes. Again, you can subtract simply, or you bring this one down, plus x2 is equal to 6. And inside this, subtract. x1 minus x1 is gone. 3x2 is equal to 6. x2 is equal to 6 by 3 is equal to 2. x2 is equal to 2. So then substitute in this one. x1 plus 2 equal to 6. x1 is equal to 6 minus 2 is equal to 4. So the point is 4, comma 2. So this point becomes 4, comma 2. Okay. 4, comma 2. This is C. And 1, comma 5 is B. Okay. Now you put the Z max values, Z min values. Okay. Z min values. What is the minimizing function? 3x1 plus 2x2 must be minimum. Okay. Now put each of the points. First point is A. A is 0, 10. Okay, 0, 10. Okay, x1, x2 is 0, 10. So 3 into 0 plus 2 into 10. 0. 2 into 10. This is equal to 20. Okay. You have to find minimum. Which one is minimum? Then here is A. B is 1, 5. This point, 1, 5. This point. Okay. 3 into 1 plus 2 into 5. 3 plus 10, 13. Okay. Next point is 4, 2. C point. Okay. A, B, C, then D. 4, 2. 3 into 4 plus 2 into 2. This is 12 plus 4, 16. Okay, then next point is 12, 0. Last point. 3 into 12 plus 2 into 0. 3 into 12 is 36. Of this, which is minimum? 13 is minimum. Okay, so Z minimum is equal to 13, where x1 equal to 1 and x2 is equal to 5. That is the answer. Okay, that's the answer. That minimum x1 equal to 5, x2 is equal to x1 equal to 1, x2 equal to 5, z is equal to 13. Okay, that is the answer. So we did the third sum. Let us do one more sum so that you get a good comprehensive understanding of what this whole thing is about. It's a very easy, straightforward thing. Let us do fifth sum. You do the other sums. Huh? Because same maximize, minimize, same thing only will become.
Okay, uncle.
Fifth sum we will do now. Maximize this time. This time, maximize. This is 10.1, 4, fifth sum. Okay. Maximize z is equal to 20x1 plus 30x2. Okay. What are the constraint given? Constraint, first constraint is 3x1 plus 3x2 is equal to 36. Okay, that is the first constraint. Second constraint is 5x1 plus 2x2 is equal to 50. Second constraint. Third constraint is 2x1 plus 6x2 is equal to 60. This is the third constraint. Okay. Okay, we'll take it like that. So first put again as usual x1 equal to 0. 3x1 becomes 0. So 3x2 is equal to 36. x2 is equal to 36 by 3. Equal to 12. X equal to 12. So x1 is 0, x2 is 12. So the point is 0, 12. Okay. This is one point. The other point now is x2 is equal to 0. That means 3x2 will become 0. That means 3x1 is equal to 36. Again, x1 is equal to 36 by 3. That is equal to 12. In this case, it becomes 3x1, 12, 0. Okay. 0, 12, 12, 0. Okay, let us do it for the other one. Here, x1 equal to 0. What happens? 2x2 is equal to 50. So x2 is equal to 50 by 2 is equal to 25. So the point is x1 is 0, x2 is 25. Okay. Now let us put x2 is equal to 0. x2, 2x2 becomes 0. 5x1 is equal to 50. x1 is equal to 50 by 5, that is equal to 10. So this point becomes 10, 0. Okay. So you have 0, 25 and 10, 25. 10, comma 0 here. Now let us go to the third one and put x1 equal to 0, get the 2 points. 2x1 becomes 0. 6x2 becomes 60. x2 is equal to 60 by 6. That is equal to 10. x2 is equal to 10. So first point is x1 is 0, x2 is 10. Okay, let's x2 is equal to 0. What happens? 2x1 is equal to 60 it becomes. So x1 is equal to 60 by 2 is equal to 30. So this point becomes 30, comma 0. 30, comma 0, 0, comma. Now we have to draw the graph. Then let us draw the graph. Biggest number is 0, 25, 30, 0. That is fine. Okay. We have to find out how we can do 2, 4, 6, 8, 10, 12, 16, 18, 20, 22, 24, 26, 28, 30. Okay, this point is 30. 2, 4, 6, 8, 10. Okay. 0, 12. This is 0, 12. First point 0, 12. This point 0, 12. Then 12, 0. 2, 4, 6, 8, 10, 12. So this is 12, 0. Yeah, this is the first line. The first line. Then second line 0, 25. This is 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. This is 25. So 0, 25 is here. 0, 25 is here. Then 10, 0. Okay. 2, 4, 6, 8, 10. This is 10, 0. So from there you have to dot 10, 0. Okay, 10, 0, we have already done. Now what you have to do, third line, 0, 10. 0, 1 is 2, 4, 6, 8, 10. So this is 0, 10. Let's take this line 0, 10. 0, 10 and 30, 0. Buddy. 30, 0 is going extremely. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30. So this line goes from here to here. Okay. Like that, this line has gone. Now what we have to do from here, maximize. We have to do maximizing function. Which one we have to take in order to maximize now? This is 0, 0. Okay. I think this way you have to go, then this way you have to go, that way you have to go. So this point you have to find out, this point you have to find out, that point. So this becomes 10, 0 becomes A. Then you have to find B, what is B? Then you have to find C, what is C? Then D is already 0, 10. Okay. Of this you have to maximize, Z maximize. Now let us first find out the intersecting point of which line and which line. 0, 12 and 0, 12, 0. First line will be intersecting with last line. Okay, that will be point C. First line intersecting with last line. 3x1 plus 3x2 is equal to 36 will be intersecting with last line. 2x1 plus 6x2 equal to 60. Okay, last line. So you can multiply this by 2. If you multiply this by 2 and put it here, it becomes 6. x1 plus 6x2 is equal to 72. You subtract this, minus 4x1 is equal to minus 12. x1 is equal to minus 12 by minus 4 equal to 3. x1 equal to 3. Now you put that x1 substitute in this one. 2 into 3 plus 6x2 is equal to 60. Okay, 6 plus 6x2 is equal to 60. So 6x2 is equal to 60 minus 6, that is equal to 54. Okay, so what that does mean, x2 is equal to 54 by 6 equal to 9. Okay, x2 is equal to 9. So x1 is 3, x2 is 9. So this point is 3, 9. Okay, where, no, not that point actually. This line 3x1 plus 3x2 interacts with this point. Okay, this point. No, correct only. Okay, last line. This is C. This is 3, 9. So I have to go back. This is 3, 9. We got. Okay. Now how to get B? B is again the point where line 12, 12, what is, which one is it? Okay. Again, 3x1 plus 3x2 is equal to 36. That line only. But that line is now interacting, cutting with this line. Which is this line 0, 25 and 10 comma a. Okay, with 5x1 plus 2x2 is equal to 50. These two lines are now crossing. Okay, now you have to multiply that with 2 and you have to multiply this with maybe 3. Then if you do 6x1 plus into 2 only, 6x2 is equal to 72. Multiply by 3, 15x1 plus 6x2 is equal to by 3, 150. Okay, now you subtract this 6x2 gone. Minus 9x1 is equal to 150 minus 72, how much? 78 I'm getting. Something wrong now. Something is gone wrong. Okay, we have to find out how this is become the problem. 3x1 3x2 is 36. 5x1 plus 2x2 is 50. That is correct. Now I multiplied by 3. If you multiply by 3 minus 15x1. Multiply by 3, 6x2. Okay. And 6 minus 15 is minus 9. 150 minus 72, how much? 10 minus 2 is 8. This becomes 4. And 82, 92, 102, 12, 22, 32, 42, 78 by 9 will be a fraction, no? So that will not happen. 1 second, let me check out 78. Yeah, that is a fraction. Not coming correctly. Let's try something else. First time 3x2 plus 3x1 plus 3x2 36. Instead of that, let us say x1 plus x2, divide that by 3, 12. Okay. Then what is the other one? 5x1 plus 2x2 is equal to 50. Yeah. 5x1 plus 2x2 is equal to 50. Now what you should do, multiply this by 2. Okay, then 2x1 plus 2x2 is equal to 24 you will get. Okay, now you subtract. Subtract, this will get cancelled. This becomes 26. 5 minus 2 becomes 3x1 is equal to 26. Uh, Either way, there's coming a problem. 2x1 plus 2x2 is equal to 24, correct. I1 plus 2x1 equal to 50. Subtract that. 3x1 there seems to be some problem. X1 is equal to 26 by 3. Again, you are getting a fraction. Again, you are getting a fraction. This is the correct region. Correct region. C is there, B is there. X1 is 26 by 3. Then now to get now X2. Okay. Okay, let us do then X1 plus X2 is equal to 36. X1 is 26 by 3 plus X2 is equal to 36. Multiply by 3. 26 plus 3 X2 is equal to 72, 108. So 3x2 is equal to 108 divided by, okay, minus 26. 108 minus 26 will be 2. 10 minus 2 will be 82 again. Okay, so 3x2 is equal to 82. X2 is equal to 82 by 3. So x2 is equal to 82 by 3. Something is wrong in this example. This problem, something is wrong. You can't get that kind of numbers. 26 by 3 and 82 by 3. Okay, let us keep 26 by 2, 3 and 82 by 3. Now we'll have to do Z max. Okay, Z max is first one is 0, 0. Okay, that is point O. Then point A is 10, 0. That is point A. Okay, what you have to maximize? 20x1 plus 30x2 you have to maximize. Okay. 0, 0, 0 plus 0 is equal to 0, matter over. 20 into 10 plus 30 into 0, that is equal to 200. Okay, second one. A. Point B only we are getting 82 by 26. 26 by 3 and 82 by 3. Okay, 26 by 3 and 82 by 3. So that is 26 by 3 and 82 by 3. Okay. So 20 into 26 by 3 plus 30 into 82 by 3. This will go 10 times. So that is equal to 820. To 20, 26 into 20 is 0 to 520. Okay. 520 by 3 plus 820. Okay. 820 plus 520 by 3. 520 by 3, 5 it will go once, 12 it will go, 12 it will go how many times? 4 times, 140 plus 820. 140 plus 820. 0, 6, 960. This is equal to 960. Second one. First one is 200. Second one is 960. Okay, then point C. Point C is 3, 9. Okay, 3, 9. 20 into 3 plus 30 into 9. 20 into 3 is 60. 30 into 9 is 270. That is equal to 330. Okay. Point D is 0, 10. Point D 0, 10. Okay, that is 20 into 0 plus 30 into 10. That is equal to 300. Okay. Of all this, 960 is the maximum. So we are getting that 960 is the maximum. Okay. If you do like this is what you are getting. I'm trying to see what is wrong with that point B. There's something wrong with that point B, which we cannot, resolve. Okay, you take this for the answer currently. I'll check if there is any mistake that can be rectified. Okay, 5x1 plus 2x2, the point B. 3, 9 is correct. 0, 10 is correct. All other points are coming correct. Why this point alone is coming wrong? 3x1 plus 3x2. Can we just do one more time? Okay, we will copy this and paste it first.
Yeah, uncle.
This, some answer has come. Copy and paste it off. Now let us go in and see if any problem was there with the two sums. Okay, two lines are 3x1 plus 3x2 is equal to 36. That is the first line. Okay. 0, 12, 12, 2. That is the first line. The next line is 0, 25, 12, 0. 5x1 plus 2x2. That is the other line. 5x1 plus 2x2 is equal to 50. This is the other line. Now, however you do it, you are not able to take away the fraction. This you multiply by 5, this you multiply by 3 and see. 15x1 plus into 5, 15x2 is equal to, again 36 into 5. 30, 3 5 are 15, 180 will be 180. Okay. This you multiply by 3. 15x1 plus 3 into 2 is 6x2 is equal to 150. Okay. Now you minus, this will go off. 15x2 minus 6x2 is equal to how much? 9x2. 9x equal to 180 is equal to 30. Okay, x2 is equal to 30 by 9. Divide by 3, 10 divided by 3, 10. This is also coming 10 by 3. X2 is coming 10 by 3. So there is something wrong in the problem. If the fifth problem comes, you don't attempt it. There is some problem in that. Okay.
Okay, uncle.
the guide and all, they are doing some Gilma and giving some answer. It is not right. Okay. Now, okay, x2 is 10 by 3. What will be x1 value?
Maybe the question is wrong, uncle.
I think the question, there's a problem. 3x1 plus 3x2 is equal to 36. Okay. So 3x1 is equal to plus 10 is equal to 36. 3x1 is equal to 26. x1 is equal to 26 by 3. Again, it's coming 26 by 3 and 10 by 3. Again, this is also not possible. So solving these two equations is giving a problem. Okay. So fifth problem, remember, if it comes, you better avoid it. Okay. Other things are not a problem. Yeah. Okay. We will finish that. That is over. You can do. We did minimizing, maximizing, maximizing. You do sixth sum minimizing. Okay, and you do
Okay,
fourth
uncle.
sum maximizing. That's all. That will be enough. Or second sum.
Okay.
Either two you do. Don't do
Sure.
all three. Just do two. Okay. Now let us go to the other chapter. We'll just start something in network analysis.
Sure, uncle.
Networks are diagrams which are usually visualized in transportation systems like roads, railway line, pipelines, blood vessels, etc. He's trying to give some examples of what a network is. Okay, railway line will be like that. Road networks will be like, when you look in Google Maps, you can see a road, the road networks. Okay, like that, it will be coming this way, that way, all that, and it will be like that. It will go this way, this way, this way, this way. This will go this way. This will go and connect this thing, something and all like that will be there. Okay, some network. Okay, blood vessels also a network. So what do you mean by network? That's what we mean by network. Railway lines also network. Pipelines, they are also network. Now, a project will consist of a number of jobs. If you take an IT project, for example, okay, what is the basic work breakdown structure? First of all, you have requirements analysis. Okay, then after that, you have design. Then after that, you have software development. Okay, coding. Then after that, you have unit testing. Then after that, you have system testing. Then after that, you will have integration testing. Integration testing. Okay. Now, requirements analysis, then designing, then coding, then unit testing, then system testing, integration testing. Within each of these, there will be so many activities. Okay, because design, you will be deciding module 1, module 2, module 3, all of that. Inside each module, you will be coding hundreds of software programs. Okay, this will run into thousands of programs. Okay, same way unit test will be in thousands. System tests will be in hundreds. Okay, integration test also will be in hundreds. Like that, so many activities. Number of jobs means so many activities will be there. And a particular job can be started only after finishing some other job. See, unless you finish the business requirement analysis, you cannot start designing. Okay, how can you design the software without knowing what are the business requirements that the client wants? So design is dependent on requirements analysis. Same way, only after you design you can start coding. So coding is dependent on design. Then after that, testing will be only after you have coded, you have something to test. Okay, like that. So these are all dependencies. So there may be many jobs which may not depend on some other jobs. Okay, for example, after I've designed, once I finish design, then let us say that one boy is doing the coding for module 1, another boy is doing the coding for module 2, third boy is doing the coding for module 3. Three fellows are doing the coding. Okay, and this fellow will do the unit testing. Unit testing this fellow will do. This fellow will do unit testing for the second program. This fellow will do unit testing for third program. That means all these three activity can happen in parallel. But by the time it comes to test the system, okay, and to do integration testing, what happens? Unless all the three fellows have finished both their coding and their unit testing, you cannot come and do test the entire system or do integration testing. Okay, you understand? So there may be jobs which may not depend on some other jobs. What jobs here not dependent on other job? Coding for module 1 is not dependent on coding for module 2.
Okay.
So I create unit testing for module 1 is dependent on coding for module 1, but it's not dependent on coding for module 2 or unit testing module 2. It can happen parallel. Okay, like that. So this network scheduling is a technique which helps to determine the various sequence of jobs. Okay, jobs means each job is an activity concerning a project and the project completion time. So what all are can be done parallelly, you maximize the jobs that can be done parallelly. Okay, then the shortest possible time within which you can finish the project. Okay, project completion time, that only you want to find out. So there are two basic planning and control techniques that use a network to complete a predetermined schedule. Okay, there are only two techniques. One is a program evaluation and review technique, which is called PERT. Program evaluation and review technique. In short, it is called PERT, very famous. The other one is called critical path method, CPM. Okay. Now, CPM was developed in 1957 by J.E. Kelly of Remington, R. and M.R. Walker of DuPont. So all these fellows, they are all working in real-time projects, and they are struggling and struggling, and then only they found out this method. Okay, they are doing this in order to help schedule the maintenance of chemical plants. So some chemical plant is going on, how to do the maintenance activity of the chemical plants in such a way that you are optimizing your time. Within a predetermined schedule, you are able to maintain the chemical plant. Okay, so that is why CPM technique was developed. So CPM technique is generally applied to well-known projects where the time schedule to perform the activities can be exactly be determined. Okay, so when you cannot exactly determine it, you use PERT. When you can exactly determine the time, you are using CPM. Okay, now let us go for some definitions. The job they were telling. Okay, job is only a inexact thing that they are using, word they are using. Actual word that you must use is activity. That activity only is a single task or item of work to be done. See, one fellow is writing a single program within a module. That will be an activity. And once he has finished that program, he is running a unit test on it. That single program is testing it whether there is any bugs in that. Okay, that will again be another activity like that. So an activity is a task or item of work to be done that consumes time, effort, money, or other resources. Of course, it will consume time. Why? Yeah. So this fellow has to sit and do the coding. No, it consumes time. It takes effort. He has to put his brain power to work. Then only you can do the programming. Then it will cost money because who will give him the computer? Who will give him the salary for doing the programming? Correct. It costs money and other resources. Computer must be there, light must be there, electricity must be there. All right. Software and hardware must be there. So many resources are required. Okay. So when you have all these things, time, effort, money, all the other resources needed, then an activity or task can be done. Okay. It lies between two events called the starting event and the ending event. An activity is represented by an arrow indicating the direction in which the events are to occur. Okay. So an event is like that. Then you put one direction and then you put another event. Okay. So this activity is this one. This is the activity. These are the two nodes between the activity. Okay. So this activity, let us say, write code for module 1. Okay, so this will be the start. event, this will be the end event. Between the start event and end event of the activity, you have the actual doing of the work. Okay. So now you know what is activity. Let us now go and find out what is event. Okay, let us go and find out what is event. Event, the beginning and end points of an activity are called events. Okay, you can call it event or you can call it node. Node A and node B, usually they call it nodes, not events. Okay, but event is a point in time and does not consume any resource. Please understand, this activity only is consuming time. This is only consuming cost. This is only consuming other resources. But this event is summa dummy. Okay, there is no time involved in that. This is zero time. The event. See, this event is the completion of writing of module 1 code. This event is the beginning of writing of module 1 code. Okay, like that only that event is. So that event will not consume any time or activity because it is not an activity. It is just a node there. The beginning and completion. Wait, let us go to the next. The beginning and completion of an activity are known as the tail event and the head event. Okay. When you begin the activity like this, you saw. Okay, this is A, this is B. So this is the head event. This is the tail event. And this is the activity. Event is generally represented by a numbered circle. Correct. Okay, A, B, 1, 2, 1, 2. Okay. The head event called the jth event has always a number higher than the tail event called the ith event. Okay. So as we go along, what happens? The number of the events continues to increase. Hey, he's giving in reverse here. How can it be like that? Okay, we'll come back to that. I think he's giving in reverse there. Okay. Predecessor activity.
Uncle, we'll stop with this, uncle. It's 6:13. Yeah.
6:13 now. Oh, I thought we can at least finish till the components. Then examples we can give tomorrow. Okay, let us only do predecessor event and successor event, and we'll stop.
Yeah, sure.
Okay, now I told you, no, first event you must do design. Design module 1. Okay, this was 1, this was 2. After you design module 1, you start doing code module 2, module 1. Okay, this becomes 3. Correct. So this is predecessor event. After you code module 1, what you will do? Test module 1. Okay, this becomes successor event. So activities which must be completed before a particular activity starts are called predecessor activities. If an activity A is a predecessor of activity B, it is denoted by A less than B. Okay. In this case, design module 1. Design module 1 is less than code module 1. Okay, like that you should say. Activity B can start only if activity A is completed. Okay, only if design module 1 is finished, then only you can start code module 1. Okay, that is the meaning of that if you put like this. Then successor activity. In activity that cannot be started until one or more of the other activities are completed, but immediately succeed them is referred to as successor activity. Okay, the important point to note is immediately succeed them. Now, as soon as you finish coding unit 1, okay, module 1, finish coding module 1, immediately you should start unit testing module 1. unit test module 1. Okay. Then only you can call it as successor activity. If after you finish coding module 1, okay, long time later you will do integration testing. Integration testing you will do. Okay. That will also come after you finish coding unit 1. Okay. After this is done, after system test is done, then after many other activities are done, integration testing will be done. Okay. Now, technically, after unit coding activity, this activity is done. After that, only integration testing is done. But that will not be called a successor activity. You understand? The activity which immediately follows the event of the tail end. Okay. Soon after 2, then it begins. That activity only is successor activity. Okay, we'll stop there and we'll come back again next class and do it. Okay.
Sure,
Today
uncle.
is what day? Tuesday. Okay.
Okay.
Thursday, I won't be here. It's a holiday, guys. So please remember. So Saturday only we'll be doing it.
Saturday.
Saturday.
Okay, I'll try, uncle. But Saturday will be in Vellore, no?
Oh, you will be in Vellore. Saturday.
Yeah.
You said you are going 14, 15.
Yeah, 14, 15, 16, 17.
All 4 days you are in
Yeah,
Vellore.
15, 16, 17. 14 is
Friday,
just,
Saturday, Sunday.
yeah, Friday, Saturday, Sunday.
Okay, then see if you can take your laptop or something and we can have some.
Yeah, I'll try, uncle. Yeah.
If you can do, we can do, because very interesting this one. I don't want you to miss this. Once
Sure,
we
uncle.
finish this, we are finishing 4 chapters. It will be
Yeah.
very interesting. We can
Okay.
start financial derivatives. Operation research is exceedingly interesting topic. Okay. So Saturday 4 to 5, I will be expecting you. Try
Sure,
maximum.
uncle. Yeah, I'll try my best.
Okay. Thursday we don't have a class.
Yeah, sure.
Holiday. Thank you, ma. Bye bye.
Okay, thanks, uncle. Bye. Good night.